Hi everyone, today we're going to be learning about the differences between DFA and NFA. As I explained in my past videos, DFA and NFA both are types of finite automata without output used for string acceptances. Now the major difference between DFA and NFA is in deterministic finite automata, each of the transition leads to exactly one state. Now since it leads to one state, that's why it is known as deterministic finite automata. We can determine that given the state, given the input, we can exactly determine where the next state would be. Whereas in non-deterministic finite automata, a transition can lead to a subset of states. For a given input, there can be more than one transition, which can reach to any number of states. So since there are n states, we can say that it can reach up to n states or less than n states, so a subset of states. So this means that some transition can be non-deterministic. They can be deterministic transition, but they can also be non-deterministic transitions. That's why it is known as non-deterministic finite automata. Leading from this difference, we can also find out the transition function. Since in DFA each transition leads to exactly one state, and here each transition can lead to a subset of states, this would be reflected in the transition function. The transition function in deterministic finite automata would be, the transition function is represented by delta, is for every state, if we give an input, we reach another state. The capital Q here represents state, and sigma, it represents input. This is a set of states, this is a set of inputs. Whereas in non-deterministic finite automata, transition function would be for every state, if we give input, we can reach a subset of states. So for subset, we write the power set of Q, which would be 2 to the power Q, since it can reach any combination of these states. For non-deterministic finite automata, there are transition for empty inputs. So there would be another, we can write the transition function for NFA with epsilon as, for every state, if we give input which also includes epsilon, then we'll reach any combination of these states. There is a major difference between the transition function of NFA and DFA, and this is the only tuple in which NFA and DFA differs. Rest all the 4 tuples, which are Q, which represents the non-empty set of states, sigma, which represents the non-empty set of inputs, Q naught, which is the initial state, and Q naught, which is final or set of final states, all 4 are same in NFA and DFA. They differ only on this transition function. The next difference, as shown in the last difference, is similar as in DFA. There is no transition for epsilon, or no transition for empty inputs. Whereas in NFA, there is transition for empty inputs, the next difference between DFA and NFA is that in DFA, backtracking is possible. This is because it is deterministic, so we can always backtrack. Since for every state, if we have an input, we can determine the next state. We can also do so in reverse. So for every state, if we know the input, we can determine from which state it came from. Whereas in NFA, backtracking is not possible. It is sometimes possible, but it's not always possible, because since DFA is also a part of NFA, so in some of the NFA, backtracking is possible, but most of the time it isn't. Next difference in DFA and NFA is based on practical implementation. Now DFA, it is understood as one single machine. It is very deterministic in nature, which the computers are very good at. So practical implementation of DFA is possible, whereas in case of NFA, practical implementation is not possible. Next difference between DFA and NFA is based on the string acceptance. Now DFA, it accepts input if last state is final. Whereas a non-deterministic finite automata, it accepts input if one of the last states is final. As we've seen before, in deterministic finite automata, there is only one path that it travels. So if that path ends on a final state, the string is accepted. Whereas in non-deterministic finite automata, there are multiple paths taken, and if a single one of those paths end on a final state, then we consider that a string is accepted in NFA. I've made a whole video explaining how string accepted by DFA and NFA. If you want to learn more, click here. The next difference between DFA and NFA is based on the conversion. A DFA cannot be converted to NFA, but an NFA can be converted to DFA. When we implement an NFA, a DFA is first NFA is first converted into DFA, and then DFA is designed into a compiler. So, and DFA is also a part of NFA. That's why DFA cannot be converted into NFA. We can restrict NFA into DFA, but we cannot open DFA into NFA. This is an example of DFA. This is an example of NFA. In DFA, if on Q0 state, if the input is 0, will remain on Q0, but if the input is 1, will go to Q1 state. On Q1, if the input is 1, will remain on Q1, whereas if the input is 0, will go to Q2. On Q2, if the input is 0, will remain on Q2, and on Q2, if the input is 1, will remain on Q2. And this is the final state. So we see that for every input there is only one transition. It is very deterministic in nature, hence it is a deterministic finite automata. Whereas in NFA, we'll start from Q0. If the input is A, will remain on Q0, but if the input is B, will remain on Q0, and there is one other transition which is from Q0 to Q1. So we have two transitions for input B, and in Q1, if we have B, we'll go to Q2. Since there are two transitions for single input on one state, hence it is a non-deterministic finite automata. Now here is a summary of all the differences.